Good morning, everybody. This is the Podman Community Cabal meeting. It is October 19th, 2023. We have a number of topics today. Generally, this meeting is held for discussing design type of topics rather than doing demos and such. And today we have 4 subjects that we're going to be talking about. The first one, Anders, is going to be talking about sharing storage between Podman and cri-o for Podman Desktop. And then Avery, thanks for coming today, Avery, as well, and Anders and others who are presenting too. Avery will be talking about building trust in containers. And then Brent will be talking about Podman machine, SSH keys, connections and namespacing. And then as time allows, we'll also be doing a very quick update from what I hear about specifying a guest OS and Podman machine init at the tail end. So with that, we've got a rather packed schedule. I'm going to hand it over to Anders.
Yeah, hi. I hope you can hear me okay.
Yeah, coming through loud and clear.
I was talking to the Podman Desktop team about different ways of being able to build and run containers. Since the 1.0 release, they have a workflow when they have a Podman machine. They start with CoreOS and interact with it, and you run your containers and you deploy a couple of pods and so on. And then you want to deploy them to Kubernetes, and then they have the option of starting a kind container in Podman. And this kind container will then run a containerd inside this container. But that also means that every time you want to build a new image, you have to do Podman build, and then you have to do Podman save. And then you have to load this saved archive into the Kubernetes cluster with the ctr import or some other containerd command. So we were talking about different alternatives, and one alternative would be to have the Podman Desktop talk directly to the Podman inside the cluster. So it would talk to the Podman inside the container. So Podman in Podman, if you will. But that one is it's an older version, and you would still not be able to use your images that you had in the other GUI. So the question from the team was if it was possible to share the storage from the Podman engine on the VM host with the cri-o engine running in a container on that same VM host. So that is something we're starting to explore. I haven't gone so very far with myself. I think the Minikube in Podman with cri-o is a bit out of date, and it has a number of bugs. So
you would launch a privileged container inside of
yes,
kind, and then have
so kind only runs containerd, and that makes sharing images between containerd and Podman engine probably more of a no-go. But an alternative would be to start a Minikube container with cri-o in very similar fashion, and then have that one share the storage. So I was wondering if there are any, I mean, is it enough to volume mount or bind mount varlib container storage and run container storage from the host, or how many other interesting issues will you run into when you have 2 engines fighting over the same storage?
I have a feeling it would work.
Because we have used it on a single machine. We use Podman to do Podman build and Podman load, and then use those images in cri-o.
Right. Container storage is set up to be able to do to handle that situation, as long as they're in the same user namespace and things like that.
I think they used to do builds in storage shared with cri-o. We eventually isolated it, but if I remember correctly, this did work at some point. But I have no idea how much trickery was involved.
And the initial approach would be to run the rootful Podman machine to cut down on the number of moving pieces. I think eventually you can have like a rootless Kubernetes cluster talking to a rootless container engine, but since it's all running in a VM, that's not the priority.
If you are sharing storage, then the build container, the supposedly unprivileged one, has full privileges of cri-o anyway, for the most part.
Yeah.
It's not written to be resilient against malicious storage content.
Yeah. The only issue I would see in this is some Kubernetes likes to monitor the amount of images and storage, and sometimes Kubernetes likes to come in and say, I didn't build that, get it out of there.
Yeah. I mean, that is correct. The kubelet will start garbage collecting the Podman machine, so that's something to look out for. I think with a newer version, you can pin different images that you care about, but it's also only support to start deleting stuff when you run out of disk. So allocating a bigger image for machine might help.
But how out of date is the Podman that's inside of the machine?
It's a Ubuntu container, so it's 3.4 something.
So 3.4 probably doesn't. Do we even have a service for 3.4? We probably the service, because pulling an image or pushing an image to container storage probably would work even with that big a mismatch.
Yeah, sure. I mean the basics work, but there'd be no fancy things.
Yeah, I mean, another thing you could do it with microshift as well. Microshift might be.
Sure. You can do the OpenShift cluster instead, and not to deploy a Kubernetes cluster at all. That could also. But anyway, that is something that is being looked into because, for different reasons, Podman Desktop might want to be able to run with cri-o.
I think the
container on Debian.
With cri-o, you don't have a problem. All the container storage locking is done inside. We don't use any tempfs, any content in /run, so that shouldn't be a problem. So as long as you have the right, it should be all right.
But you do need both var and run, right? So you need the run root and the root to have the locks and everything in place. I need to map.
You have to, Nalan, do you know if there's? I don't think container storage does any locking in.
It doesn't put lock files in the run root. It stores them under the root. That's why it has to be rewrite. So I expect it would work, but yeah, the main thing I would worry about is garbage collecting. From one to the other.
I think that's a later concern, but it's ongoing. With Kubernetes 1.29, it started to garbage collect the paused image in Docker. That's interesting for those. So let's see if Mirantis hurry up with backporting the support for pinned containers. Otherwise, there will be garbage collecting thing. But the paused image is small. You can pull it quickly. No, that was just the topic. I linked in the chat. I linked to the Minikube issue and like the alternatives and so on, if you are interested in this. I think it will be ongoing in Minikube. I'm not sure how much the Podman Desktop team will be involved in it, other than trying to make it work from the interface. But
just got to get Minikube to move to cri-o, get off of Ubuntu. No problem.
Sorry, you mean to change? I think changed their container from Ubuntu to Debian.
Yeah.
So the Minikube container is just suffering a bit of neglect. It hasn't moved in a while. But that would also be possible.
Yeah.
Right now it's sharing the image between all the runtimes. So it runs Docker and Containerd and cri-o. And the cri-o is also willfully out of date. I think it's like 124 or something. It's supposed to be, I mean, reasonably within versions of the Kubernetes. They have now started to release cri-o in lockstep with Kubernetes, so each Kubernetes release will have a cri-o release.
Any other thoughts or comments here before we move on? Anders, you mentioned a link, but I don't see it in the chat.
Sorry, it was in the document in the HackMD.
Okay.
But I can post it in the chat as well. But
yeah, I got it.
And yeah,
I'll add those to the notes. And thank you. So next up, we're going to be talking about building trust in containers. Avery.
Hi, thank you. I'm going to share my screen if that's okay.
Sure thing.
Okay.
If the meeting gods will allow it.
All right, great.
Looks good, coming through just fine. And would you mind sending me this after the meeting in PDF or something?
Yes, for sure. So hi, I'm Avery. I'm a first-year PhD student at Duke, and I'm going to be talking about our ongoing efforts to build trust in containers. And so our proposed solution is centered around leveraging the power of cryptographic measurements rooted in trusted hardware. So we're working from inside the operating system to use cryptographic measurements and attestation to build a framework for verifying container integrity. And so I started this work actually as a Red Hat intern. So it's fun to be back here. So here's a background on some of the technologies that we're using to build this solution. So we use the Trusted Platform module. And so the Trusted Platform module serves as a dedicated cryptographic processor designed to secure hardware. Some of the key components that we're using in this solution are secure storage and unique hardware identities. So TPMs contain a number of platform configuration registers that can be changed by firmware in the OS only by concatenating with the prior value held in the register. The TPM is used in applications such as secure boot, disk encryption, and attestation and trust through technologies like Keylime. And the Linux integrity measurement architecture is used to measure file integrity throughout runtime. This currently cannot be used on containers because these measurements are not namespaced. IMA does the measurement, appraisal, and storage of file integrity data. These measurements are provoked when files are mapped with an executable protocol, and IMA creates a hash of the file contents and stores them in TPM-based non-reputable logs. These files can be measured based off system policy and are used to detect changes in file integrity due to remote or local attacks. And for some more background, attestation involves the verification of system integrity relying on these cryptographic measurements and trusted hardware. The TPM enables remote attestation from boot measurements throughout runtime using the IMA logs and the measurements conducted by IMA throughout runtime. You see a diagram here of how Keylime can be used to attest an environment through registration and verification of the IMA logs using a TPM quote. And so in our solutions, we use a variety of kernel extensions. Kernel extensions are user-defined programs loaded into the operating system kernel. Kernel modules are used for adding device drivers or file systems to load into the OS. We also use eBPF, which is a mechanism that allows for user-defined programs to run sandboxed in the operating system kernel. And so this is useful for a variety of applications because of the wide variety of hooks located across kernel subsystems. And so the first step of finding the solution was extending IMA to containers using eBPF. This was possible through the LSM hook mmap file, which we used in order to grab the files that were mapped as executable through an eBPF hook that we placed, and then setting a callback to the kernel module that we defined to add namespacing to this measurement. This is important because, as I had said previously, IMA currently does not have namespace support in the kernel. And due to this, we were unable to verify the integrity of individual containers from these measurements because you can't differentiate between a host measurement and a measurement of a container. And so through leveraging the kernel support of eBPF, we can add namespace support without requiring changes to the kernel. And so eBPF provides the visibility that we needed to measure a container's executable content without requiring changes to the OS. We used a sleepable eBPF program to hook into the mmap file LSM, which is actually the same LSM hook used by IMA to provoke measurements inside the kernel. And so we used a patch that was available in kernel 6.0, which allowed eBPF programs to use kernel module functions. And so in our kernel module, we defined the routines for measuring and storing integrity data. We did this through utilizing some existing IMA infrastructure, and we added namespacing to these measurements and extended them all to the host hardware TPM rather than having a TPM per container. And so from here, we have measurements of a container's executable content throughout runtime. But as you can imagine, doing attestation for a system like this is extremely complex. It requires building a policy for each container that would run on the system. So while we have this integrity measurement for the containers, what can we do with them? It becomes more and more complex to do attestation at this scale. So we seem to be kind of at a crossroads of how can we measure container integrity from here, which led us to our next solution. And so from the operating system, you have very little visibility into container creation. And so through using the unshare system call, which is central to container virtualization, we're able to have a little bit of visibility from the operating system level. So the unshare system call disassociates parts of a process's execution context that are currently being shared. And so through looking at the unshare system call, we can filter based on policy to have visibility into the container creation process. And so from unshare, we're able to see the current task that is being disassociated. And when we're looking at this task, the file system of the task is the container image that is being started. So from unshare, we're able to get the information of the new namespace that is being created for this container, as well as the container image that is being started. And so we added a LSM hook into the unshare system call to provoke this measurement based off of a policy. And so this hook provides a callback to functions that we have defined in IMA to measure the container image based off of the policy. The introduction of this hook also allows for future work on appraisal and access control from the operating system level. And so as we talked about the complexity of creating a policy for container attestation, having these IMA measurements of a container in a log just means that the IMA log is just going to grow increasingly with the scale of the container. And so having a single measurement for each image really cuts down on this complexity. And so we propose a single measurement for the image, which is created through traversing the file system and concatenating after each measurement. We do a depth-first traversal of the image file system and form a single measurement for the container that we then write to the IMA log with its associated namespace. And so these image digests are stored as a single entry. They are logged with a namespace as their identifier, and they are extended to the PCR of the TPM. This image might be small, but you can see that a container image was measured with its namespace. This image also shows the IMA extension where it executed something called hello. And so you can see the differentiation between a system with namespacing versus not. And so we're also working on policy enforcement. And so to measure this based off policy, unshare is being called for more than just container creation. And so having a system policy that can be changed dynamically is what we would need to determine what flags would provoke a measurement or what environment would need to be measured when unshare is called. And so the overhead for measuring these images is not too terrible. The security comes at a price. But this benchmarking is done on container startup time when the image is measured with a machine with a hardware TPM. And so, as you can imagine, current image digests that are provided by container repositories are dependent on image layers, manifest files, IDs, and times. And from the operating systems level, the only thing that we really have visibility into is this final file system image. A digest of the image itself is needed to provide the extension of the chain of trust from hardware to each container image. And so our question today is, what does the path to kernel verifiable measurements of a container look like? Because as we can create these measurements from the operating systems level, we have no way to verify against the container provider or the container maintainer what if these image digests that we're storing and creating are correct. We would need a kernel verifiable container digest to be provided that we could then build policy based off of. And so future work is to improve policy enforcement and connect container attestation with Keylime. And that's most of what I have for today. But I'd appreciate.
So I got a couple of questions for you. First of all, have you looked at all at what we're doing with ComposerFS?
No, I have not.
Okay, so that's something that you should investigate. So ComposerFS is doing sort of a DM verity of content put down on disk. So it's similar to what you're trying to prevent, and that's what actually Giuseppe on this call is actually working on. So you should take a look at that and see if there's overlap or something you can take advantage of in that category. Other issues I see with what you're doing is how do you handle volumes? Because you could get random content. I mean, I can mount /user over /user inside of a container.
Mm-hmm.
And what happens then?
Yes, that's kind of where we need to deal with policy. We only really see the container image, and so volumes are left behind in this scenario.
Okay, because when you say an image too, you're talking about a rootfs, right?
Yeah.
Because all you're saying is that the mount on share had happened, and then mounted this rootfs, and then so you really don't even understand how the relationship between that rootfs and the original image name that was pulled down to be right. And so you're looking for some way to track that back to something like what Podman did to start that image, right?
Yes, we have the namespace that we can associate with the measurement versus the container running on the system, but that's the connection that we have now.
Yeah. So David asked you a question.
Yeah, hi. Thanks, Avery. That was really interesting. You might also be interested in reaching out to my former team at Azure Research. We did the initial version, what was deployed as Azure Confidential Containers. So this gives you attestation over containers running in TEs with Rego policy to tie that into whatever your constraints are. The version I did was running in SGX enclaves, which had awful performance. The one that actually shipped is running in SNP VMs, but that's actually now a deployed product. And so I think they'd be really interested in looking at some of what you're doing and seeing if there's any intersection.
Great, thank you.
David, can you send a mail to Avery, or are you willing to share here on the chat?
I just found you on LinkedIn, so I'll ping you there.
Oh, thank you.
So other things that you might want to look at is actually hooking into Podman has the concept of OCI hooks, and you could use the OCI hook to basically garner information about the application that's about to call unshare. So I'm not sure it's called. I guess it's Giuseppe. Is it called unshare at that point?
The Cisco, yeah.
Yeah. So basically, we can call Podman will call a program, or any of our container engines will call an executable right after it establishes the container, and will provide information, basically the entire OCI runtime information to the application. So so if you had a hook, you could garner all the information from Podman that this is what is run, this is the command line that's being executed, and then that would give you information, actually information that you could even display to the user or in your logs to say that, you know, container ID, blah, 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 using image, you know, Fedora, you know, executed this command and failed an IMA test. Because that's really what you need. Mm-hmm. So look up OCI hooks. And I think just about, Run C does it, and C Run. So actually this isn't even specific to Podman, or you can do it with Docker, you can do it with any of the container engines that use an OCI runtime hook. So that would be where you would garner additional information that would, then you could use that to have a database of what the IMA measurements that you want to hook up to your system are. The reason Compose.fs is interesting to us is that it takes care of it would take care of the content, making sure that the content wasn't modified, so that, we pull down an image from the internet. We want to make sure that the content of the image has not been modified after. So during the pull, we use signatures of the image that's pulled down. When we write that to disk, we're actually able to write stuff to the Compose.fs database, which also goes through a similar chain of trust, and we know that the file's has not been modified. But what we don't know is whether or not the container was run with the correct command. So your check would be looking to say, I downloaded this executable and I expect it to be run with this command, and not some bash script or something like that. And so you could argue that yours would be more secure. But I think what you really need to look at is whether or not Compose.fs and your thing would plug in together. The other thing you'd be able to tell by using an OCI hook is whether or not there's volumes mounted in. So if you have a volume mounted in, your IMA says that's illegal, or you don't want volumes mounted in, then you could block the execution of the container at that point.
Mm-hmm. Great, thank you. I'll look into that.
Yep.
Any other questions or comments? I want to wrap this up. It was a great talk, but we do have another topic or two to go. Right, I'm going to hand it over to Brent then to talk about Podman machine SSH keys and connection name spacing.
Thank you, Tom. Would you mind pasting the links in there just for those that aren't following the agenda? There were 2 links on the agenda. But while he's doing that, that just sort of fills in some of the gaps. I think generally the core team is pretty aware of this problem, and there have been community members or non-core members, let's just say, that have tried to submit PRs about nibbling in on a fix on some of this. But the base problem, or the base problem statement here, is that Podman uses, when you do a machine init, it kind of has all these different places it has to go and set up. So there's a machine name, there's SSH keys that it needs to write, and SSH connections. If we just primarily look at those 3, right now we don't detect collision on SSH or system connections until the machine is almost totally initted, which means it's gone through a pull, it's gone through a decompression and a disk resize before it catches it. Now, Ashley just added some really good code in with callbacks that go and clean that up after the fact if something fails. And I'm sitting on a PR that checks system connections before really any work gets done and fails the init if there's a collision. But the SSH keys get kind of interesting because today we don't check. We generate a key. We use the keygen and we give it the name of the machine, and it goes, and if it fails, it gives sort of a benign whoops error. So that's not the ideal user experience, but all these different approaches have kind of come up with, do we need to namespace somehow our machines either by the provider or by identifying it as a Podman machine component? So, for example, should the key be written to something like .ssh/podman machine/mynewkey so that we don't have collisions with other keys? Same with system connections. I guess theoretically you could have a system connection with a name and have the same machine name and want to somehow keep that working together. But this idea of namespacing has been kicked back and forth for quite some time, and with Podman 5 beginning to sort of come together in terms of what we want to do, I'm wondering if we need to go down this rabbit hole here. Those 2 links that Tom posted then are sort of the feeders for this issue. So I'll stop talking and see what folks think. Cool. I'll do what I want.
Do you have to put the keys in .ssh, or can they just live in the Podman machine namespace somewhere, like a key file?
Yeah, I think that's exactly it, Anders. It's a matter of where does it look. I'd have to look at, I'm not intimately familiar with the options about where to write with the SSH keygen, but my assumption is there's a way to prefix it to get it where you want.
Yeah.
And is that overly confusing to people? You know, are they looking for that key in .ssh? Do they care? Those kinds of ideas.
So what we ended up doing for Lima was to generate the SSH config. So in order to do a SSH, you only have to do the -f, and then you will get all the parameters for the connection, including key and the user and so on.
Does that mean that all the keys are going into a singular file?
So it generates a key that is shared with all the VMs, and that goes into a file under the Lima configuration. And I think when we started it would also copy all existing keys from .ssh into authorized keys on the VM. But it turns out that some people have a large number of keys in their .ssh, and it just and then there was also some, well, maybe not security, but yeah, it went from opt-out to opt-in, at least, to copy all existing keys, but that's different from where you generate the keys.
Indeed.
Yeah. But I mean, the downside of that is that you have to do a -i or -F or something to specify where your key is hiding.
Yep.
Or mess with a key agent or something.
Well, we do that today anyways because of the key limit of 6. And
right.
A lot of people, including me, suffer with that because we have more than 6 keys.
Yeah.
I think we also hide that within Podman machine, right? So it's right. We can figure out where the keys are based on the machine that you're trying to start.
Yeah.
Yeah. So it can be hidden from the user. I like that. I mean, I want to get to multiple machines running simultaneously. So I think having a private Podman machine SSH key file somewhere would be fine. And to me, that makes sense.
What if folks think of a singular key?
A singular key for all machines? That's fine too.
That makes a lot of sense to me.
Yeah.
Paul or Matt, you guys have danced around those SSH issues as well. Anything to add?
The most important thing to me is that the key be easily, as a user, I want to know where the key is easily. If we do a single key, that's fine. Report it via machine info. It's just that when things go wrong, I want to be able to craft my own SSH command to get into that VM because Podman machine SSH has decided to blow up or whatever. So I think it's a good idea. Just give me a way to get the key on my own that doesn't involve going through 50 directories on Windows trying to find where it lives because Windows doesn't really have a .ssh native.
Right. We do have this nice directory on all our providers, which is tilde config containers Podman machine. So we could stick it at that level, use the same key for all providers. Anyone see any downside to having a singular key? Remember, it's a passwordless key.
The only thing is when we remove a machine, we have to maybe add a flag that says remove key instead of --save keys and not remove it by default.
Aren't you using the same key for every machine?
Yeah, so right now when we remove the machine, we remove the keys. So we have to make sure we preserve the key in case another machine is using it.
Right, yeah. Stop removing the keys. Create the key once and use it everywhere.
Okay. So generally supportive of this idea, it sounds like. I don't think it'll actually be all that hard to implement either.
I don't see there's no security risk because it only goes one way. It's not, you're not setting up a trust from your host, from the VM back to the host. So since it's only one way, you're just copying your public key into the SSH daemon on the other end. So it's not really a huge risk that I see.
And you already
we do allow user injection of it. Go ahead, Anders.
You already mapped your home directory into the machine, right? So
yep.
the secret is out there.
we probably should have mounted that directory into the machine.
I think it came down to a matter of like difference in philosophy between like Podman Machine and Podman Desktop, if you will, and that is the VM a VM or is it the extension of your host? Like, should you have access to everything on your whatever Mac Windows host in the Linux VM because it's just the extension of that host, or is it a separate entity with a different user and a different key and so on? So there are no right or wrongs to that issue, but we came from different places on the machine versus desktop.
Yeah, I think most users expect their home directory to be present in the machine, though. So.
Yeah, unfortunately.
Yeah.
One of those things inherited from Docker.
Yeah. Well, I think also because that's the way things like Visual Studio and things like that sort of make that requirement.
Tom, I'm happy.
Okay. Did you want to touch at all upon the other topic that we had here earlier? The guest OS.
He's still on. Is it David?
Yes.
Right? He's David. You're still on my list. I got yanked into some prioritization exercises that took all my gumption away from reviewing, but I owe you a review. I don't think our commitment to you has changed in the sense that we would like to see a provider for FreeBSD machine, but still shy away from the guest OS aspect of that. So we'll work with you on that, and I'll get that review here as I unbury myself.
Yeah, I made the changes that we talked about last time. Yeah, and then I hit an issue that the firmware variables file system flag was set incorrectly, which I saw you fixed yesterday. So thanks for that. Mm-hmm. So now that that's fixed, I'll do a bit more testing and see why CI is unhappy with me.
All right.
Should I put another topic in the next meeting for this as well? Or at least
if you like, we can do a checkpoint.
Okay. I'll add that for the next one. Which, before I forget, we are, due to conflicts with meetings for most of the folks at Red Hat on Thursdays afternoons that have come up recently, we're going to be moving the Cabal meetings from the third Thursday to the third Tuesday of each month. Okay, so from one T to the other T. And so they'll still be at the same time, 11 a.m. Eastern, UTC 5 by the time we get to the next one, which will be on Tuesday, November 21st. And our next community meeting, where we do more demos and that kind of thing, is on December 5th, which is also a Tuesday, which is the first Tuesday of the month. So we'll have meetings on the first and the third Tuesday of the month, although the first one of the month is every other month on the even months. And that is all that we had for the topics that were defined beforehand. Does anybody have any topics or questions they'd like to do themselves? Brent?
I'll give everyone else a chance, but if we need to fill some time, I would love to give an early present to everyone and maybe talk about a few Podman 5 things.
So before we get to that, I'm going to put Urvashi on the spot here. Urvashi and I've been, Urvashi's been working on this project that, along with Nalan, to do what we're calling Podman BuildFarm, Podman Farm Build. The basic idea is to make it easy to build multi-arch images. So if you had two Podman machines or two or more Podman connections to other machines that are running on different architectures, that you could assemble a multi-arch image from a container file. So you give a container file, it goes out to 3 different Podman services somewhere on the internet or on your local machine, and assembles the image, creates the image, then creates a manifest, pulls the images from those machines back to the original machine, assembles an image, and then allows you to assembles a manifest list And then you can push that manifest list and all the images up to a container registry, and you have a multi-arch build. So Herbishi's being very quiet here, but one of the interesting things is that works very well on a Linux box. But if you run it on a Mac or a Windows, where are you going to be, where is the assemble point for the image? Where are you going to create the manifest list? Where are you going to pull the images to? So say you're building x86 and I don't know, power all at the same time. You want to pull all three of those images back to the primary machine and then create a manifest list. So Herbishi, you want to talk about where we're currently thinking?
Yeah, sure. So last that we had a discussion, we were thinking of basically pulling the images from the machines or the VMs onto the primary machine, not Podman machine, onto like the local like Mac or Windows basically. So that will probably be pulled in like a dir format. And then we can push that to the primary machine so that it can end up in your container storage. So then when you do Podman images from your client, you'll be able to see that manifest list and images there as well. The reason we need to, I believe, pull it onto the Mac directly first is because the Mac is the one that would know about the connections that we have with the other machines. That's where we store the system connection information and the farm information and the containers.conf file. So that's what we were thinking, and that's kind of something I'm testing out. I haven't completed that yet, so that's a work in progress. Right now, the local Linux work is done, and the PR is about to be merged hopefully soon. I think it's in its final stages of reviews. So once that's in, then the next part would be getting this working on the Mac with the remote case.
Yeah. So the primary machine in that case will be the default.
Yeah.
Podman machine.
Yes.
Does anybody have any thoughts on this? Is everybody thoroughly confused by what we're doing?
I think the VMs or the images, the individuals, can be pushed from the VMs, and then the manifest list be assembled locally and then pushed. This would prevent pulling the images around.
I think the issue there is that the primary machine wouldn't have information of the connections and the farm. Like that would be stored on the Mac itself, I think, because that's what the containers.conf file is. So that's why we were thinking it has to come first to the Mac and then go there instead of us trying to figure out how to set up those connections from the primary machine as well.
So if the idea is to push the manifest list, then I think the push can be done from each of the connections individually to the registry. Then the Mac client knows which images have been pushed. He knows the digests. And then on the Mac side, on the client side, the thing that has to be done is then to create the manifest list or the OCI index. And it's pretty much just the JSON file. And I think this can be done in the OCI transport locally, which works on the Mac and Windows as well.
So when you say on the Mac, you're talking about in the machine or on locally on the Mac?
No, on the client side. So the individual images that are, the multi-arch images, the individual ones could be pushed directly from the VMs, from the machines.
Right.
Then they're on the registry and we have the digests.
Yeah, you create a manifest list assembled with the digest. Basically, it's just a JSON file locally on the Mac or the Windows box, and then you're going to push that to the registry as well, right?
Right. So once the individual images are pushed, you know that they're on the registry, then you can create the manifest list or the OCI index with the specific digests. Those have to be known. And then you don't have to pull n images around, but you can push them once, then assemble the JSON file and push it to the registry.
So basically, then this one exists in your local storage, right? You're just pushing it directly to a registry.
Well, container storage does not exist on the Mac.
I'm talking about the primary Podman machine that has container storage.
Yes, there the image, you can push it directly to the registry. So to avoid conflicts on the tag, you can do a digest push. So you would do, instead of having a tag, you can specify the digest. I see Milislav unmuting. Maybe he has thoughts as well.
Yeah, there's a snag in there in that you can't do a digest push without first compressing the data. And CImage doesn't really have a way to do that right now. Like you could do it if you know the digest in advance, but you don't.
But after building the image, you know the digest.
Random tag and then delete the tag, but it's something that probably can be built in some other way.
Go ahead, Nolan.
One thing I would worry about in that case, well, actually two things, is A, you'd be sharing the credentials that you use to write to the registry with whatever your endpoints are that are doing the build work, and assuming that they can connect to the registry. You also have, as Miloslav said, you would have to tag it because you can't push the digest until you know the digest, and that may change during the push. Problem with trying to untag an image is that a registry that's doing aggressive garbage collection will get rid of that image very quickly, perhaps before you even have a chance to write a manifest list that references that image that you just pushed.
I'm not that worried about the credentials because I would assume that I have to trust the registry where I built my images on, because this is where, potentially my sensitive data will be in any case. I maybe need even credentials for pulling. So I would guess that the credentials for pushing would be, or should be, okay.
Isn't that more of a requirement than from the user to have, get into the machines and get all the credentials and everything set up there before they can do these builds?
Well, presumably
credentials are passed from the client side. You don't have to set them up. Those are part of the REST API.
It was a great discussion, and I think we can go on for quite a bit more, but we've only got a couple minutes left in the meeting.
All right.
Urvashi, could you include a link to the PR that you're working on in the chat? And I'll go ahead and include it in the notes. And if folks have further talks, we can do that there, and/or we can add a topic to the next Cabal meeting if that's appropriate. And thank you all for that. And Brent, did you want to do a quickie on the 5.0?
Probably not, but what I can do is say that there will be a Podman 4.8 coming out in November sometime, and we have planned for, and in some cases begun to work on a Podman 5 that should theoretically come out very early next year, and we'll continue to share as we go along with that. We intend to branch after we release 4.5. I'll repeat that. We plan to branch Podman 5 will be the main branch after we release 4.8. I think that keeps you more on time.
We had talked about a 4.9 for RHEL, but that'll just be like a 4.8.5 or just bug fixes for 4.8. We'll go to the next route, right?
Yeah, I don't know. I was just thinking whether or not we'd release that to Turtle, or but probably so, I would think. The 4.9 or whatever. But 5.0 is the target.
I mean, there's no reason to go to 4.9 unless we add new features. So, but yeah, if we add new features, then we'd have to go to a 4.9. But it'll be very limited features if there is any.
Right. Any other questions, comments, thoughts? David did bring up a note, I think, aimed at you, Urvashi, in the messages in the chat. And I'll let you take a look at that and digest that on your own. And so again, the next Cabal meeting will be on Tuesday, November 21st at 11 a.m. And the next community meeting will be a couple weeks after that, after the Thanksgiving holiday in the US on December 5th also at 11 a.m. Eastern Time. And with that, I'm going to close up the recording. And thank everybody for coming here today.